Hey everybody, and welcome back to our next video in Unit 4, which is all about balancing chemical equations. This is something that you might have done maybe in like your 8th grade science class or 7th grade, or maybe even in 9th grade science. I'm not sure, but you might be familiar with balancing chemical equations already, and this relates really nicely to the law of conservation of mass, which we just talked about. So the law of conservation of mass says that mass cannot be created nor destroyed in an ordinary chemical reaction. And we looked at the masses of reactants and products, and we were able to determine if I have a certain mass of two reactants, what would the mass of one product be? And basically, it all comes down to making sure you have balanced chemical equations. So let's take a look at this equation right here. So of course, we're familiar with looking at these already, and you have been able to determine your reactants versus your products. So your reactants are always on the left side of the arrow, whereas your products are always on the right side. If you look at this particular reaction, this does not satisfy the law of conservation of mass. If you look at the reactant side, you have two bromine atoms as reactants, but you only have one bromine atom as a product. You can't lose atoms as a result of an equation. You must satisfy the law of conservation of mass. And to do that, we have to make sure we know how to balance chemical equations. There has to be the same number and type of each atom on the reactant side as there is on the product side. So normally this helps students by looking at pictures. So here's a potassium atom, and here's a bromine molecule. So in this case, bromine is bonded to itself, hence it's represented by two of these dark blue spheres. And when these come together, you form a potassium bromide formula unit. So here's your potassium atom, and here's your bromine atom. So this equation right here is not considered balanced, and that's because the number and type of each atoms are not equal on both sides. So a chemical equation is considered balanced when the ions or atoms found on the reactant side are equal to those found on the product side. So in this case, this equation is not balanced, and the arrow can in fact be considered the balance point, of course, because it separates your reactants from your products. And like we've said already, this equation is not balanced. How do we go about balancing chemical equations? We have to add coefficients to the front of all of your atoms or molecules or ions that are in a chemical reaction. So let's take a closer look at this one. Again, sometimes it helps students to have to look at a picture to represent this. So if I were to start balancing this, let's just start with potassium, just because it's the first atom that's listed. I have one potassium on my reactant side, and I have one potassium atom on my product side. So potassium is balanced. This does in fact satisfy the law of conservation of mass. However, let's look at bromine. I have two bromine atoms in my reactants, but I only have one bromine atom in my products. I can't, again, lose a bromine atom throughout this equation. So what happens is one of these bromine molecules can form two of these potassium bromide molecules. And that's because these bromine atoms actually split up. So one's going to go here, and the second one's going to go to your other potassium bromide formula unit. And what we do is we show that by drawing coefficients, or rather writing coefficients. And your coefficients tell you how many of each molecule is present in the balanced chemical equation. So one bromine molecule can produce two potassium bromide formula units. Now, what does that do to potassium? Well, now my potassium is out of whack. So it looks like I need to add another potassium on my reactant side. 2 potassium atoms can produce 2 potassium bromide formula units. In this case, this equation is now balanced. You have the same number and type on both sides. So great job. This equation is now balanced. That's me. That's you. We're very happy. We're learning how to do this. Here's another example. A little bit trickier, but still not undoable. So I have aluminum fluoride and bromine forming aluminum bromide and fluorine. Again, draw a picture if it helps. So here's an aluminum fluoride formula unit, a bromine molecule, and the rest of it's there. Let's just do aluminum first, just because it's the first one that's listed. I have 1 aluminum in my entire reactant side. So there's my aluminum represented right here by this light blue circle. 1 aluminum, my reactants. Let's look at the products. 1 aluminum also in the reactants, or in the products, I'm sorry. So this is balanced. So we're actually not going to start off by balancing aluminum first. Let's try fluorine. So it looks like I have 3 fluorine atoms on my reactant side. I have 1, 2, 3. Let's look at the product side. I have 2 fluorine atoms on the product side. We have to find the least common multiple of 2 and 3. So what value can I get to that is a multiple of both 2 and 3? Hopefully I'm saying that correctly. But your least common multiple, therefore, is 6. So you can get 6 fluorine atoms going in by adding a coefficient here, and you can get 6 fluorine atoms coming out. And you could do that by adding some more of these molecules. So how many of these aluminum fluoride molecules do you need to have to get to 6? 2 of them, right? Because I have 1, 2, 3, 4, 5, 6 fluorine atoms going in. And if I look, I have 3 groups of 2 fluorine atoms coming out. So there's a total of 6. We're going to add coefficients to the front of those to show that 2 aluminum fluoride molecules can produce 3 fluorine molecules. 3 times 2 is 6. 2 times 3 is 6. What does that do to my aluminum? Aluminums aren't balanced anymore. So what do I need to do here? How many aluminum bromide molecules can I make? Well, hopefully you said 2. So therefore, I would have to add a coefficient of 2 in front of aluminum bromide. My aluminums are now balanced. How many of my bromine molecules can I produce? Well, if I have two groups of 3, I have 6 total. And again, if you're not sure, look at the pictures. 1, 2, 3, 4, 5, 6. How many groups of 2 gives me 6? Hopefully you would say 3. So in this case, this equation is now balanced. It satisfies the law of conservation of mass. The same number and type of each atom is present on both sides of the arrow, in the reactant side and also in the product side. So these are some of my master balancing tips, which you're going to get much more comfortable with balancing as you do it. And I'm going to kind of read through you these balancing tips kind of as we go through, but I would recommend reading these on your own, maybe after we go through these balancing problems in this next section. I'm going to cut to the note packet. We're going to write on the screen, and we're going to do sample problem 5 with balancing. This is going to take a little bit of time, just like how moles took a little bit of time to learn and get used to them. This also takes a little bit of time to learn and get used to them. And I feel like once you get it, you get it. Like once you can balance, like you can balance really, really well. And it's interesting because I'll hear like the little light bulbs go off around the room once students kind of understand how to balance equations correctly. So anyway, let's just go ahead and do some of these together. So like I said, you'll start to get very comfortable with these as we do some of these. And some of them are easier than others, but let's just dive right in here. So let's go ahead and start with A, balance the following chemical equations. So again, this arrow right here is kind of like our balance point. We are always going to look at what's on your reactant side versus what you find on the product side. The number and type of each reaction must be the same on the reactant and the product side. Let's look at iron first, just because it's listed first here. So it looks like I have one iron atom on my reactant side, and I also have one iron atom on my product side. Therefore, irons are already balanced. What I like to do though, this is a tip of mine, and I'm just going to tell you the tips as we go through. If it's already balanced, just leave it, because most likely you're going to have to go back and change that. So don't write any numbers here yet. So I'm just going to skip it. And let's go to the second element here. I have 2 chlorine atoms going in, and I have 3 chlorine atoms on my product side coming out. So that is not balanced. We need to find the least common multiple of 2 and 3, which we already determined in that last problem was 6. So how many groups of 2 gives me 6? 3. And how many groups of 3 gives me 6? You should find 2. So chlorines are now balanced. And what I like to do when I'm done balancing one is I put a little check mark above that element so I know that that one is finished. And I only check them off on my reactant side only because I don't think you have to do it on both. Notice that that did in fact change the ions. So now I have 2 irons coming out, which means I need to have 2 irons coming in. So let's add a coefficient of 2. And remember, these numbers are what we call coefficients. So this number here, this number, and this number, we call those coefficients. Coefficients. They're the numbers that we add to the front of each of those. We don't want to change these guys right here because then it changes the overall composition of the molecule. Let's try the second one. So again, if you want, if it helps identify your reactants and products, here's my reactant side, and here's my product side. You don't have to do this, but it might help. One of my other tips is to skip anything that's by itself first. So here, notice how magnesium is going to be pretty easy to balance. You can put any number in front of here. So I'm going to skip magnesium, and I'm also going to skip manganese, only because, like I said, those are going to be pretty easy to balance. I'm going to go right to oxygen, only because it's bonded on both sides here. And again, you'll start to learn some techniques as you go through. On my reactant side, I have 3 oxygen atoms going in, and I only have 1 oxygen atom coming out on my product side. I need to put a coefficient of 3 in front of magnesium oxide here. Because I'm not adding anything here, I am a firm believer of putting 1s there. You don't have to put 1s, but to me it looks finished that way, and I know I've already balanced that reactant. So I always like to put a 1. That now I can balance manganese because I have that coefficient of 1 there. 1 group of 2 manganeses. Looks like I need to have 2 going out. And I have 3 magnesium atoms on my product side. Now remember, I have 3 groups of this whole entire thing. So you have 3 magnesium atoms. Looks like I need a coefficient of 3 there. So this equation is also now balanced. The number and type of each atom is the same on both sides, so it satisfies the law of conservation of mass. Here's a pretty easy one too, and it only looks tricky because you have that 8 there. But sulfur is actually pretty easy to balance. So if I look here, I have 8 sulfur atoms on my reactant side. I need 8 in my products. Right now I only have 1. One of this whole entire sulfur tribe, is what I call them, can produce 8 of those SO2 molecules. So 1S8 can produce 8 SO2 molecules. Sulfur is now balanced. What coefficient do I need to put here in front of oxygen? Well, in my product side, I have 8 groups of 2, which is 16. I also need 16 here. And what a lot of students will do is they won't think twice about it and they'll put 16 there. That's incorrect, because if I have 16 groups of 2, that technically gives me 32. So I don't need to put 16 there, but instead you need to put a coefficient of 8. 8 groups of 2 also gives you 16. So just be careful that you're being mindful of these subscripts. These are subscripts and these are coefficients. You try D. Actually, you try D and E. Both of those are pretty easy. So give those a shot. Pause this video. Try to do those. And I will have these answers up here for you right when you come back. There is your answers for D and E. So not too bad. Fluorines here. I have to have 6 because I have 6 fluorines in my products. And I can get a nice number of 6 just by adding a coefficient of 3. 3 groups of 2 is 6, 1 uranium, and I have 1 uranium going in. In this case, I just need to add a coefficient of 2 in front of hydrochloric acid, and that balances out chlorines. So I have 2 chlorines right here, and I have 2 hydrogens right here. This equation is also now balanced. Let's take a look at F. I have a trick for F, and my trick is for water right here. When I see water, I normally write it as HOH. I don't know why. It just makes it a little bit easier for me to balance. And that's because if you look, I have an OH on the end of water, and I have an OH right there on this potassium hydroxide group. And what you'll also see is I have a hydrogen in water, and I have a hydrogen right here. I think it's a little bit easier to balance by looking at it that way, but ultimately it really doesn't matter. Let's go ahead and take a look at this one. So I have a potassium going in, and I have 1 coming out. That's balanced. I'm going to balance this hydrogen with this hydrogen here. And that's because this hydroxide group is already balanced. So notice I didn't put a coefficient of 1 in front of potassium. And that's because, again, kind of leave it if you don't have to put anything there. So I'm going to add a coefficient of 2 here. And that makes my hydrogens that are in pink balance each other out. Let's go ahead and balance these green groups here, these hydroxides. So I have 2 OH groups going in. I have to have 2 OH groups going out. Those are now balanced. And let's look at potassium. Now I have 2 potassiums in my product side, and I have to have 2 in my reactants. Again, that's why it's important to usually leave those ones for last if they are already balanced. And if you choose not to write this as water, you'll see that it is in fact balanced already. So if I have 4 hydrogens here, 2 groups of 2 is 4. I must also have 4 in my products, but you have to be careful because both of these products have 2 hydrogens each. So I have 2 here and 2 here, which gives me a total of 4. This one looks scary, but it's not too bad. So let's see. I'm going to skip carbon first, only because that's a pretty easy one to balance. Let's do hydrogen first. I don't know why. I'm just feeling like doing hydrogen first. So I have 16 and 1. Looks like I need to put 16 here. And let's put a 1 there. Hydrogens are balanced. What does that do to carbon? Well, hopefully you would say you'd have to have 10 carbons on my product side. And what number has to go here? Well, if I have 16 chlorines, how many groups of 2 gives me 16? hopefully you would say 8. That is now balanced. Try H. H isn't too bad either. Give this one a shot. There's the answer for H. Not too bad. Let's try I. I looks a little crazy. Here's another one of my tricks. When I see a lot of subscripts here, especially with higher numbers, I just like to balance something there first. I don't know why, my eye just immediately goes to the ones with a lot of the numbers, and I balance those guys first. So let's just go ahead and do aluminum, just because it's the first one listed here. Looks like I have 4 on my reactants and 1 in my products. I need to put a coefficient of 4 there. Let's put a 1 there. Let's balance carbon. 3 total carbons, 1 groups of 3. Gotta have 3 here. That guy's done. Let's do oxygen. So I have 4 groups of 3, which gives me 12 total oxygens. So I also have to have 12 oxygens here. And what a lot of students will do is they'll leave it and they'll move on. And what I always recommend you do is double checking this last one. So let's go ahead and double check that. We're going to need, let's use this nice gold again. So let's identify reactants and products. And let's consider just the hydrogens here. So on my reactant side, I have a total of 12 groups of 2 is 24. I have 24 hydrogens, which means I have to have 24 hydrogens in my product side. 3 groups of 4 is 12 hydrogens in CH4, and 4 groups of 3 is also 12 hydrogens here. 12 plus 12 gives you 24. So this hydrogen is in fact also balanced. I highly recommend just double checking to make sure that it is in fact balanced before moving on. And let's try J. J is a fun one because you'll see there's lots of these parentheses, and you don't have to go crazy balancing every individual element separate from one another. This SO4 group and this SO4 group, those are kind of like one family. We call this in chemistry the sulfate polyatomic ion group. We're going to keep those together and balance those as a whole. In the same way, we're going to look at those other ones, and I have OH and OH. That also acts as one unit. So we're going to balance those with one another. So if you see something is present on both sides, balance them as a whole. Makes it a little bit easier that way. So there's one tip. And again, my other tip, I see lots of subscripts here, so I'm going to try to balance these guys first. Let's balance aluminum. 1 going in, or 2 going in, 1 going out. Let's add a coefficient of 2 and 1. Aluminums are done. Let's try sulfate. I have 3 of this whole SO4 group. So I must also have 3 of this whole SO4 group here. I only have 1 of them right now. So if I have 3 total groups, that gives me a total of 3 sulfates. So put a little check mark there. Let's balance calcium. I have 3 calciums in my products. I need 3 in my reactants. Done. And let's do this OH group. Again, this is called the hydroxide. We're going to balance it as a unit. So I have 2 of these in each molecule, but I have 3 molecules. 3 groups of 2 is 6. And on my product side, 2 groups of 3 is also 6. This equation is now balanced. And you can always go back and look at these tips here. So I kind of told you some of those as we were going along. Balance one element at a time, balance the atoms of elements that are combined and that appear only once on each side of the equation. Polyatomics, that's the one I just told you. we're going to get some more practice with these last two in class. This is something, again, that takes a lot of practice. It does not just come to you after doing 10 practice problems. So this is not the only time we're going to balance. We're going to get lots of practice with these in class, just like we did with moles. And I have a really fun balancing activity we're going to do with this. If you have any questions, make sure you ask them to me in class. And again, if you're a little overwhelmed, that's okay, because that normally happens with balancing. It does take a little bit of time to truly grasp the material. Otherwise, that's the end of Unit 4. So we're trucking along over here, and I'm really excited to get into Unit 5. Unit 5 has some fun stuff in it. So ask me any questions you may have when I see you next, and I will see you in the next video for Unit 5, all about electrons. Bye.